Hello guys, welcome back. Today we're going to be solving week 4 chemistry quiz. So let's directly begin. So the first question says, which of the following factors increase the rate of a chemical reaction between a solid and an aqueous solution? So before we look at the options, let's try to give an example. Let's say we had MgCO3, which is a solid, and it gives us MgO, which is also a solid, plus CO2 gas. So this is a chemical reaction. We want to increase the rate of the chemical reaction. So what usually increases the rate of a chemical reaction? So of course, temperature. So if I increase temperature, I will have a faster rate. And why is that? Because when I increase temperature, the kinetic energy of the particles increases. So they build up speed and they start colliding with each other. So this is the collision with each other more frequently, which increases the rate of chemical reaction. So increasing the temperature is one of the options. Now, increasing the surface area of solid reactants. Of course, if I increase the surface area, they're going to be smaller molecules, so they're going to be more likely to bump into each other, which will also increase the rate of reaction. Addition of a catalyst, of course, remember, what do catalysts do? Catalysts lower the activation energy. If you guys remember this graph, so we have two types, if it's endothermic or exothermic. So this is exothermic because we released energy, while this is endothermic because we absorb energy, remember? And we said that this is the energy of activation. So what does a catalyst do? A catalyst increases the rate of chemical reaction by decreasing this activation energy, so it needs less energy to go to the product side, so therefore increases the rate of chemical reaction. And of course, if we increase the concentration of the aqueous reactants, they're more likely going to have collisions, and that's why a faster chemical reaction. Now, if we increase the volume, think about it logically. If I have a small box or I have a large box, in this large box, they're going to be spread out more, so they're less likely to collide with each other. However, if I have a smaller volume, they're all close to each other, so they're more likely going to react with each other, which increases the rate of chemical reaction. So this is wrong. It should be decrease in volume. Okay, let's go next. Calcium carbonate and hydrochloric acid react as we show in the reaction below, and they're telling us which diagram would be suitable for studying the rate of the reaction. Of course, so if we want to study the rate, we have to check what are we producing. So we're producing CaCl2 and CO2, which is the gas. Forget about the water. So if we want to measure the gas, of course, we need something to measure the gas, and of course we need the stopper. So we don't want the gas to evaporate, to leave our beaker or our flask. We want it to be measured in this thing right here. So 3 would be an option. That's to measure our CO2, and also to measure our CaCl2, we'd need the balance. However, this time, we would need a balance to measure, so we're going to choose 2. Okay, because here, we're also going to be measuring our CO2, but we don't want to measure the CO2, we just want to focus on the CaCl2, which is measured using the balance. Okay, perfect. Which of the following best defines chemical kinetics? So kinetics is very simple. It's a definition you have to know. Kinetics is basically the study of reaction rates. That's it. Okay? So we have a following reaction. Experiments show that the reaction is extremely slow at room temperature. So what does it mean when a reaction is slow? Remember, we usually break bonds in our reactants and we form bonds in our products. So if it is slow, that means it involves a lot of breaking and the formation of new bonds. All the other ones do not determine why it is slow. Okay, so they could be right, but it's not absolutely true. We can't be 100% sure that that's the reason why. However, this, we can know that that is the reason, because that's what happens in a chemical reaction, basically. Okay, let's go next. How does the increase in the concentration of reactant affect the rate of a chemical reaction according to the collision theory? So collision theory is basically when you have a reactant, two reactants, or it could also be one only. So we have a reactant with another reactant, and they are reacting with each other to form a certain product. So if we increase the concentration of the reactants, they're more likely going to collide with each other. That's according to the collision theory. So we will have a faster reaction rate. So it increases the frequency of collision and thus increases the reaction rate and not decreases the reaction rate. Perfect, let's go next. So a jar flask containing N2 and H2 that reacts to form NH3 as follows. Which of the following increases the rate? So we're also looking at increasing the rate. So decreasing the volume occupied by the mixture, yes, we explained already why that would happen. And of course, if we increase the amount of our substrate, which is N2 or reactant, so increasing the quantity of N2. And of course, if we decrease the quantity of H2, we'll have a lower reaction rate. Perfect. A block of wood burns with oxygen in the air at fixed high temperature. So we have wood and oxygen, okay? How can the rate of reaction be increased? So remember we said if we increase the surface area of a reactant, we're going to increase the reaction rate. So if we cut the wood into smaller pieces, if we grind the wood, because it's going to have a larger surface area, now we need O2 as a reactant. So what are we going to do? We're going to increase the concentration of O2. How do we do that? We replace air by pure O2, because air only has around 21% O2. So if we replace air by pure O2, of course the rate of the reaction is going to increase. Based on the collision theory, a decrease in temperature, as we said, temperature affects the kinetic energy of the particles. So if we decrease the temperature, less kinetic energy, less speed, they're not going to be colliding with each other as much. So it will decrease the rate of reaction, decreases the rate of reaction, because the number of effective collisions between particles also decreases. Okay, perfect. Okay, this question we've already solved it before, so I'm just gonna skip it not to waste time. If you don't get it, leave a comment down below. However, if you also may check my previous video, I explained it perfectly over there. Same thing for this question. I'll just remind you it's bonds broken minus bonds formed. So we do the reactants minus the products. I also explained it in my previous video, so make sure to check it out. Okay, so we have three different experiments, equal masses of excess calcium carbonate were reacted with the same volume of hydrochloric acid. In each experiment, only one factor affecting the reaction rate was changed, and we were measuring the volume of carbon dioxide released. Okay, so before we look at the options, let's just look at the graph. So the steeper the slope, the faster the reaction rate. You guys have to know that. So of course, A has the steepest slope. So A is going to have the highest reaction rate. Okay? Now between B and C, as you guys can see, C has a steeper slope, so it begins faster. However, it reaches a lower final volume than B. B catches up with A. So I need you guys to think about that. That means in C, we're decreasing the amount of substrate we have, amount of concentration we have. Okay? So let's look at the options now. A lower temperature, of course, a lower temperature, it won't decrease the amount, we'll just have a slower rate. So it's going to be graph B. A lower concentration of hydrochloric acid. Now we're decreasing the amount of our substrate. So of course the final amount is going to decrease, that's why it's going to be C. Using lumps rather than powdered calcium carbonate. Remember, powdered calcium carbonate has a higher surface area. Lumps have lower surface area. So of course, we're going to have a slower reaction rate, but the volume of CO2 won't change. That's why we're going to choose graph B. And of course, the addition of a catalyst, it's going to be graph A, because it is the fastest reaction rate. Okay, choose the correct answer to complete the following sentence. In general, if the concentration of KiO3 is decreased, then the rate of the reaction. Now let's look at KiO3. Where is it? So KiO3 releases K plus and IO3 minus. So IO3 minus is in our reactant part. So if we decrease the concentration, of course, the reaction rate is going to decrease. Okay, same thing here. They're telling us if the temperature decreased, of course, the reaction rate will decrease also. Choose the correct answer to complete the following sentence. The reaction rate of the reaction can be expressed as the quantity of. So here we have to look at the products, and usually reaction rates are per unit time. So we look at the products, we could say it's H2O per unit time. Okay? Make sure per unit time. And finally, we have also two graphs. A lower temperature, of course, it's going to be graph B because A has a steeper slope, so it has a faster reaction rate. So of course, lower temperature means lower reaction rate, so that's graph B. A higher concentration, of course, it's going to be graph A. Now, a greater reaction rate, of course, also it's going to be graph A. And a smaller surface area, of course, it's going to be graph B. If it was a larger surface area, it would be graph A. And the addition of a catalyst would be graph A also. Okay, that's it for today's video. It's a very quick quiz. I wish you the best of luck in your exam. Don't forget to like, comment, and subscribe, and share it with as many people as possible. And if you have any questions, leave a comment down below. Thank you guys, and best of luck.